Assalamu alaikum wa rahmatullah. This is Abdullah Badr, Oxford School's International Section, and this class is assigned for grade 11 IG AS students. يعطيكم العافية شباب. Today, inshallah, we're going to continue what we started in the last video about the halogenoalkanes. Just to remind you guys, for the last videos, we explained what's the meaning of halogenoalkanes, those organic compounds with a halogen bonded to one of the carbon atoms, either chlorine, bromine, or iodine. And as we said in the last video, fluoroalkanes, iodo, or astatinoalkanes, we don't need to discuss them, inshallah. And we named some compounds, we draw some compounds, and we stopped at the types of halogenoalkanes. And we said there are three types of halogenoalkanes: primary, secondary, and tertiary. To remind you guys, كمان مرة, primary halogenoalkanes, in which the halogen is bonded, or the carbon bonded to halogen is directly bonded to one carbon atoms. Carbon bonded to halogen is directly bonded to two carbon atoms. This is a secondary halogenoalkane. And for tertiary halogenoalkanes, the carbon bonded to halogen is bonded to three carbon atoms. Today, inshallah, or in this video, inshallah, we are going to continue and to talk about the reactions of halogenoalkanes. The reaction we need to talk about, the first reaction we need to talk about is the nucleophilic substitution reaction. Nucleophilic substitution reaction. Before we start, let's define a nucleophile. We took in the unit 1 شباب electrophile وأخذنا and I defined the nucleophile بس again إن شاء الله عشان to remind you. Electrophile, this particle or this species that negative charge loving species, يعني هم عندهم positive charges أو partially positive charges, هدول electrophile. أما nucleophile is the positive charge loving species. يعني هو بده يكون either negative أو عنده lone pair of electrons. Be careful شباب, either lone pair of electrons أو هو عنده negative charge أصلا أو partially negative. Nucleophile is a positive charge loving species. هو بده يكون either positive charge. Nucleophile either بده يكون بده يكون negative charge زي ما نحكي مثلا OH minus، أو يكون عنده pair of electrons زي الأمونيا، أو حتى water molecules considered to be nucleophiles since they have lone pairs of electrons. ثواني بس. Let's make the video clear. Okay, OH minus with a negative charge, NH3 as an example that has lone pair cyanide ion with a negative charge on nitrogen. Or it might have a partially negative charge. So in all cases, those nucleophiles attracted to positive or partially positive charged species. So let's start by the first reaction, which is preparing alcohols out of halogenoalkanes. To prepare alcohol from halogenoalkane, let's say we need to react it with potassium hydroxide, sodium hydroxide, any alkali solution with solvent is water. Be careful شباب. Aqueous solution means solvent is water. Says why you are talking about this, or you concentrating on this? Because inshallah in this video we are going to introduce other solvents like ethanol or alcoholic solvents. Be careful for this reaction, specifically this reaction when halogenoalkane reacted with potassium hydroxide or sodium hydroxide dissolved in water, you prepare the alcohol substitution reaction. OH minus substituted Cl. Cl is a partially negative. OH minus is a negative ion or nucleophile. So a nucleophile substitute another nucleophile to produce the alcohol. In this case, we have 1, 2, 3 propanol and KCl. Nucleophilic substitution as we used to do. It's easy question. But inshallah in the next video or in this video if we have time. The problem is I can't make long videos. I'm sorry shabab, because it's hard to download or to upload on the YouTube takes a lot of time. That's why I am making the videos a little bit smaller or shorter in time. But inshallah, I will keep doing videos to cover the whole material if we start. بس المهم إنه all of you guys to be safe. طيب. The other reaction بس هون بالله معلش to clear أو to make the idea what we talked about clear. شوف, this is the chloropropane, chlorine, the halogen bonded to carbon dipoles, polar bond, since chlorine has a higher electronegativity, which makes chlorine partially negative, carbon partial positive. The nucleophile is going to attack. We will talk about the mechanism inshallah in the next videos. The nucleophile attacks the partial positive carbon and kick out the nucleophile away. We will talk further more about the mechanism, nucleophilic substitution mechanism, in the next videos inshallah. But let's make everything clear. يعني in this video I'm going to introduce the reactions, the conditions for the reactions, and the next videos inshallah I will explain more about the mechanism. طيب خلينا نشوف one more reaction. One more reaction. تعال انت هون. We have the reaction to prepare amine groups أو amine compounds. We have halogenoalkane react with ammonia ALC. Be careful شباب. Alcoholic ammonia. Ammonia dissolves in ethanol. Ethanol here used as solvent, not aqueous solution. احنا we used to have between parentheses in chemical equations solid, liquid, gas, and aqueous. In this video we are introducing ALC, which means dissolved in alcohol. ALC, dissolved in alcohol. Most of the cases we have ethanol as a solvent. Be careful, كمان. They're going to ask you about the conditions for this reaction. We have a sealed, or you need to have a sealed container. يعني you need to make this reaction under high pressure. أو simply close the container عشان to keep the pressure inside the chemical reaction. To produce, شوف, chlorine is going to be substituted by nitrogen in ammonia, and we said ammonia is a nucleophile since it has a lone pair. So it goes and displaces chlorine atom in chloroethane to produce, chloroethane to produce ethylamine. أستاذ شوف, أو be careful, ethylamine C2H5NH2. I will teach you guys inshallah where the hydrogen went. How NH3 comes or becomes NH2. So the name, بهمني النيم كتير, ethylamine, C2H5 meth ethylamine, plus طبعا hydrogen chloride, not hydrochloric acid, hydrogen chloride gas. طيب, if we have excess of halogenoalkane, C2H5, this reaction can be continue to produce different products. So another chloroalkane, chloroethane, reacted with the product that we have here, ethylamine, chloroethane with ethylamine, since we have more hydrogen atoms to be substituted, شباب. In ammonia, we can substitute more and more and more. We can kick out all of the hydrogen atoms. So to produce diethylamine, شوف, one of the hydrogen atoms راحت من NH2, شوف, صارت NH, and we have diethylamine plus the common product HCl, hydrogen chloride gas. If we have excess, still another product can be produced. And again, we have chloroethane plus diethylamine to produce triethylamine. وكمان we can make this, or this reaction can be continued to produce tetraethylammonium chloride. But I'm not going to write the fourth reaction عشان to keep things easier for you guys. بس the point here إنه it can be continued. We could have different products. We could have ethylamine, diethylamine, triethylamine, and one more product which is called tetraethylammonium chloride with the formula C2H5 by 4N. وبتكون ال N positive ومعانا chloride negative. This is the salt tetraethylammonium chloride. This is for reaction 2. Let's introduce to you guys the reaction, or the last reaction, or the third reaction in this video, which not a weird reaction, but is a very important one. And I will tell you why it is a very important. The third reaction, let's say we have this bromopropane, halogenoalkane, and we react it with potassium cyanide. Cyanide ion is the nucleophile here to substitute the halogen. The product, شوف, started with, be careful شباب, how many carbon atoms we have? 1, 2, 3, bromopropane. We ended up with 1, 2, 3, 4 carbon atoms. The fourth carbon atom came from the cyanide ion, Cn-. So you started with bromopropane, 3 carbon atoms in the hydrocarbon chain. You ended up with 1, 2, 3, 4 carbon atoms in the hydrocarbon chain. What's the name of this compound, أستاذ? عد الكربونز. meth, eth, prop, bute. Be careful شباب. Butan nitrile. Nitrile group is when we have this, let me draw it for you guys عشان to make it clear. Butan nitrile. خلي الفيديو بس ثانية. Okay. This is butan nitrile. شوف, we started with 3 carbon atoms. This is the most important part شباب, إنه هو nucleophilic substitution عادي, Cn- substituted bromide ion. بس be careful إنه number of carbon atoms 1, 2, 3 bromopropane goes to butan nitrile. صار في عندي 4 carbon atoms in the compound, and after this we could, or the chemists could either put a oxidizing agent or reducing agent to get rid of the nitrogen. So this reaction, nucleophilic substitution or substitution, or to make nitrile products, is used to increase the carbon chain. يعني you start with 5 carbon atoms, you substitute the halogen by a cyanide, you end up with 6 carbon atoms. يعني you start with, or you might start with let's say bromohexane, you end up with heptane nitrile. So this is the note, the very important note. This reaction is used to increase the length of hydrocarbon chain. You start with 3 carbon atoms, you end up with 4 carbon atoms. Those are the major reactions for the halogenoalkane substitution reactions. In the next video, inshallah, I will explain the ثواني بس. Okay. Inshallah, in the next video, I'm going to explain the mechanism and the reactivity of halogenoalkanes. What about the structure, Ustaz? What about the halogen bonded to the carbon or to the alkane? More and more, inshallah, stuff to end the halogenoalkanes topic. We'll start with alcohols, naming, drawing, types, reactions, mechanisms, how to prepare. A lot of stuff, inshallah, are waiting. A lot of stuff is waiting to explain inshallah in the next videos. يعطيكم العافية شباب. أنا عبد الله بدر, مدارس أكسفورد كمان مرة. Be safe. والله يحميكم. هاي آخر إشي. الله يحميكم. السلام عليكم.